An agent can run the same task under Instruct. Reasoning, tool use, multimodal, and long context setups, and each setup still needs a different context policy. Each configuration expects a different input structure, needs different room for generation, or carries different state between steps. Wrong role formatting can make an Instruct model misread authority. No output reserve can leave a reasoning model without room to think. Too many tools can crowd out the task, and a large window can still bury the evidence that matters. One agent task does not imply one context policy. I'm Mehrdad, and in this video, we'll see exactly how context management must change for each configuration. Before comparing them, one correction matters. These are not 6 mutually exclusive species. Base versus Instruct describes training. Chat and tool use describe interaction protocols. Reasoning describes inference behavior. Multimodal describes the kinds of input and output. Long context describes capacity. One model can be Instruct-tuned, reasoning-capable, tool-using, multimodal, and long context at the same time. In this video, model type is shorthand for the configuration active on a particular call. What matters is not the label on the model. What matters is the contract the application must satisfy. Let me give you a practical, real-world use case. Should we approve a refund outside the normal policy? With direct completion, the application builds one explicit prefix containing the policy, evidence, and request. With instructor chat, those pieces become messages with different authority. A reasoning configuration needs additional room for thinking and the visible answer. Tool mode adds order lookup and refund eligibility definitions, followed by calls and results. Multimodal mode adds a receipt, an invoice, or a product photo. Long context mode can load more of the authorized case history. The business question stays the same. The shape of the model's working context changes. In the rest of this video, we'll focus on Instruct and chat, reasoning, tool use, multimodal input, and long context. If this is useful, like the video and subscribe for the rest of the series. Instruct models expect the message format used during post-training. A chat API may show system, user, and assistant objects, but a template compiles them into one token sequence with role markers, separators, and a generation marker. The same messages can compile differently across models, so use the selected model's template. Count the rendered request too. Boundaries, examples, files, images, tools, and provider formatting all use context. Exact overhead varies by model and endpoint. Manage the sequence the model receives, not just the objects your code stores. Formatting decides how roles are encoded. Authority decides what the model should trust. Put application policy in the supported system or developer channel. Keep user content, retrieved passages, uploads, and tool results as data, because they may contain stale or hostile instructions. Retain only the conversation turns needed now. Enforce permissions outside the model. Role hierarchy guides behavior. It cannot authorize an action. Reasoning needs a different budget. You have to reserve room for the work after the input. A reasoning configuration starts with ordinary instructions and evidence, but the model may generate internal reasoning tokens or thinking blocks before the visible answer. Those tokens use generation capacity. Tool calls and structured output may need room as well, so the context budget is not simply the maximum window minus the prompt. It must reserve space for reasoning, tool interaction, and the answer the user will see. If the input consumes the entire allowance, the model may stop early, omit the answer, or have too little room for the reasoning mode you selected. Providers expose these limits and counters differently, so use the selected model's documentation and measurements. The stable production rule is simple. Budget the whole trajectory, not only the input. Headroom solves only one reasoning problem. Multi-step continuity creates another. Depending on the provider and endpoint, a response may include opaque reasoning items, thinking blocks, signatures, or a dedicated reasoning field that must be returned in a particular form. These artifacts are not one portable transcript format. A human-readable summary may help an operator, but it is not automatically a valid replacement for provider continuation state. Preserve required artifacts exactly, associate them with the correct turn-in tool call, and remove or compact them only under the provider's documented rules. Treat reasoning continuity as protocol state, not ordinary prose. Video 6 will compare the provider-specific approaches. Tool use expands context in two directions. Before the model chooses an action, it receives tool names, descriptions, input schemas, and sometimes provider-added instructions. After execution, the conversation gains the call, its arguments, a call identifier, the result, and possibly an error or retry. For the refund task, expose the order lookup and eligibility tools when they become relevant. Do not send an unrelated enterprise catalog on every turn. Preserve the link between each call and its result. Reduce a large result to a bounded typed observation while keeping the raw response in external storage for audit or later retrieval. Tool definitions are model-visible context, and tool results need a retention policy of their own. A multimodal API may accept a receipt, invoice, image, audio clip, or video, but the media does not sit beside the context for free. The provider transforms it into model consumable representations, and those representations count against model-specific limits. Select only the pages, regions, resolution, detail level, audio span, or video frames the task needs. Keep source identifiers and ordering so a claim can be traced back to the original file. Use the provider's token counting or estimation tools rather than guessing from text length. Exact accounting varies by model and modality. The durable rule is that media competes with instructions, evidence, reasoning, and output for finite capacity. A long context configuration enlarges the envelope. It does not change the categories competing inside it. Instructions, task state, evidence, tools, protocol state, reasoning reserve, and the visible answer. Research has shown that performance can vary with evidence position, semantic difficulty, distractors, language, task complexity, and sequence length. These studies do not prove one universal failure curve for every modern model. They do show why an accepted input length is not the same as reliable use for your workload. Set an operational threshold below the hard limit. Then test important evidence in different positions. Add realistic distractors and contradictions, and measure the actual task. A larger window tells you what can fit. Evaluation tells you what the application can trust. So, how do you choose? Route by the active contract, not after the model. Before each model call, ask 6 questions. First, which chat template and instruction hierarchy does this model expect? Second, how much room must remain for reasoning, tools, structured output, and the visible answer? Third, which continuation artifacts must survive unchanged? Fourth, which tools and observations are relevant now? Fifth, how should media be selected, ordered, and counted? Sixth, what input length has this exact workload shown it can use reliably? Those answers determine the active context policy. Choose that policy with the model, not after the model. If this helped, subscribe for more context management in agentic systems. Next, we'll explain why maximum context is not effective context.